Hello, statistics student. This video is for chapter 1.2. We will actually do a lot of topics in 1.2. First is types of data. We want to classify data. And then we want to look at how we can do sampling, because last time we say if the sample is not good and it's not random, it's biased, the prediction that you have for generalization is not valid. Right. And lastly, we talk about how behavior of sample. So um, if you collect different sample, they're gonna have variation. So uh, how do we explain that? So first, types of data. If you collect a data variable, they could be quantitative or categorical. So the first way to classify them is the nature of the data. So categorical usually is referred to a name, a label, or a categories. So they are also known as qualitative data. It's the quality of your subjects. And then the other types is quantitative. So this is a numerical value. So we call them counts or numerical measurement with units. And out of quantitative, there's two types. One is called discrete data. They are actually finite numbers or counts. They take on finite values. So they are whole numbers, most likely 1, 2, 3, like that. And there is no 1.5. Say, for example, how many pets do you have? You cannot say 1.5, right? How many cars do you have? You can say 1.5. So they're discrete number. Continuous are usually measurement data. You can measure it to whatever infinitely many possible value you can between two values. Um, it is only limited by the measuring device, or sometimes we reported it by rounding, but the nature of the measurement can have any number in between two values. We would say they are continuous. Now, continuous does not mean that the data continuously change. Say we measure height of a kid, so the children's height changes, or weight of an adult, so our weight changes, in a daily basis or what. So continuous has nothing to do whether it change or not. When we collect data, whatever data it is, that's what we collect. We are referring to the fact that, for example, weight of a person, so between 120 pound and 121 pound. Also, there is any number in between them. So sometimes we round our weight into whole number pounds, but actually if you have a data device that is accurate, you can measure it up to 120.5266, right? So it's the nature of the measurement. If it can hold infinitely many possible values, so it is a continuous data. Like length, you know, weights, money, times, those are usually continuous data. Another way to classify data that I want to talk about here is called level of measurement. This in the book is in 1.3, but I move it around here because it's just another way of classifying data, primarily because of the needs in psychology. When you are collecting psychological data uh, that describe people's behavior, emotions, sometimes the number that you collect is is difference when you are assuming different value. So it has four levels. The first level is called nominal level, where the scales are they are categorical data, and the number or whatever that you collect is just a categorical data. There's no natural ordering. Ordinal data are categorical data with natural ordering. So you can order it. So for example, small, medium, large, that would be the t-shirt size that someone wear, right? Um, Another would be a rating of a movie, 1 star, 2 star, like that. The third is interval scale level. Interval scale level usually are measuring quantitative data. It is a numerical value and it rates something, but there's no natural zero. The zero value is actually a mark. So it could means it's neutral. It doesn't mean it's nothing. So if a particular value has interval scale, or interval level, then the difference is meaningful, but ratio is not meaningful. A common interval scale level would be temperature. So when we say 0 degree, doesn't mean that there is no temperature. It's just at that point where it's 0 degree. So you can have -1, -2, right? So negative is possible. Positive is possible. And 0 is just a mark. Another example of interval level would be year. Year as in name of the years, like year 2000. Year 0 doesn't mean that there's no year. It's really a label where it is the point where it's before Christ or after Christ. Okay. Ratio level is describing quantitative data that has a natural 0. So how much do you earn? I earn $0. So that is 0. That means nothing. And so in this case, 0 actually means no measurement. How many siblings do you have? 0. That means nothing. Okay. So if a measurement is in ratio level, differences and times in ratio is meaningful, are both meaningful. And for nominal and ordinal data, because they're categoricals, usually we summarize them by finding proportion of a category, and you do not calculate mean of nominal or ordinal data. So for example, very often we use student ID or social security number to represent the name of a person. So social security number or student ID are numbers. Does it mean anything if you add those numbers together and find the average? Mean means the average, right? So they are not meaningful, although they are numbers, but because they are nominal data, they are name or labels, we do not recognize average. So first example is classify some data that are given or collected by looking if they're categorical. And then look at if it is discrete or continuous, if it is quantitative, and also classify the measurement also. Number of students. So it is a number, right? So in a Zoom meeting, you count the number, so it's a count. So it is quantitative. And these numbers are always whole numbers, and I think they're finite. So it is quantitative discrete, right? In terms of level, 0 means 0. So ratio level. So these are the first way of classifying. This is the psychology way of classifying. Major of a study. So you ask the students, the data values would be, oh, I'm majoring in psychology, I major in business, I major in computer science, right? So those are the data values, and those data values are actually a name, right? It's a name or label, so it's categorical or qualitative. What level does it have? It's just a name. There's no ordering, so I would say nominal. Student ID. Student ID it's a number, but this number does not measure anything and it's not a count. So it is categorical. It is actually just a name. They use a number to represent the name of a student. Now, student ID can be sorted in a certain order, but the main use of a student ID is actually the name, and name does not describe any category per se. So I would say it is nominal. You can sort them in order because it is written in numbers, but doesn't mean that there is any natural ordering. Jersey numbers. So jersey numbers are like you wear a basketball a game at the back of the t-shirt. There is a jersey number of the person. It's actually a name, right? It's categorical again, and it's just a name, nominal. Yeah, the times it takes to complete a worksheet time. So time is a quantitative data of 1 second or 30 minutes or whatever. So it is quantitative. Is it a discrete data? It is continuous because you can think about there's any number in between 2 seconds or 2 minutes. And then it is ratio because when time is zero, it is really zero, although it is not meaningful. But when time is zero, it is zero. Grade of an exam, I would say it's categorical, right? When we say grade, usually it's like the ABC grade. And can I order it? Yes, ordinal, because it's like A, B. So this is the there's a special the natural ordering. Temperature, high temperature in a city. Um, it's a number, right? So its number is quantitative. And for temperatures, you can have a number in between any degree, so it's continuous. That means you can have 65.2, anything in between. And does zero means nothing? No, zero is just a position. So it's interval level. Oh, so that is how you classify data. Why do we want to classify data? One use of classifying data is so we know how to summarize them. Okay, so in the next video, we'll talk about how to summarize categorical data. And then the third part, we'll talk about sampling method.